Hello friends, myself Neeraj Kumar Mishra and we are from Bapuji Institute of Engineering and Technology and we would like to present our project coin-based mobile battery charger with ultra-high security for the competition Texas Instruments India Analog Design Contest 2013 and 2014. And this is our whole project. Now this is a basic MSP 430F5529 experimental board which is the heart of our project. It runs all these components. This is an LCD which shows what to do next to the user, means the procedure sequence by sequence. This is a keypad which takes input from the user like mobile number and pin number. This is a door for security purpose again. Now let's see the basic hardware of our project from inside. First of all, this is our coin slot. Whenever coin enters from this slot, this IR transmitter receiver pair gives a high signal to the microcontroller, and according to that the amount will be notified. This consists of a basic LM741 op-amp and an NE555 timer. This is our basic power module. This gives power to our battery charging module and to our bridge rectifier, which in turn gives a 12 volt DC supply to our sense circuit. This is a very important part of our project because it senses whether the battery has been placed properly in the slot or not. If the battery is placed properly, then it will give a high signal to the microcontroller, or else if the battery is not placed, it will not give any high signal to the microcontroller. Here we have replaced our battery charging module with a light bulb to show the basic charging. Suppose if the battery is charging, then the bulb will glow, and if it is not, the bulb will not glow. And this is connected to 220 volt supply through this relay module. Whenever the relay is turned on using the microcontroller for the duration which is specified again by the amount you have entered, this bulb will turn on, indicating that battery has been placed and it is charging properly. Now this is our basic solenoid driver. As I have mentioned in my project report also, that our BJT driver was not working properly for driving the latching type solenoid. So we designed this circuit, soldered it, and here's the output that this circuit consisting of two relays and two transistors drive this solenoid forward and backward direction both. Now I would like to show you our door for security purpose. It is a sliding door which slides like this, and for locking the door, the solenoid just comes forward and locks it. Now it is impossible to open the door until this solenoid is turned back. Now this action of coming forward and backward of solenoid is controlled by this microcontroller only through this drive. Let's see the basic model of our project. How does it works? Here you can see that two phases are there, plug in and unplug. One master phase is there which is not visible to local people for high security reasons. It is only visible to authorized person so that it can be open in case of door blocking. Now let's go for plug-in phase, means charging our mobile. I am pressing 2. It is asking for entering your pin. Now we keep it very short for our convenience, but for security reason we will increase it further. So I am increasing a single digit pin. Now again it is asking for confirming the pin. If the pin is right, it will ask for mobile number. Enter your mobile number and it will ask for confirming your mobile number. So now enter it. And now it is asking for enter the coin number, how much coin you want to enter, means amount you want to enter. So if I am entering, now it is asking for entering the coin. See, it is asking for keeping the battery properly, means if the battery is placed properly, now if the battery is placed, it is asked for latching the door. Now the door has been latched and it can't be opened. See, it's very tight. It's a high security. Now it's charging. After some time, the charge will go off and we can take the battery in unplugging phase. See, charge is over. And for getting, I have to press R. Now again from starting it will come, and now I want my mobile back. So I have to press 1 for unplugging phase. Now I have to enter the same pin which I entered earlier. Now see, the door is open and my battery I can take out my battery from here. Now let's see what happens in master phase. Suppose you went to the booth but you forgot your password. Now let's see what happens if the charge is over and you forget your password. See, the charge is over, the bulb is switched off, but then also it is showing that charge is over. Press 1 to go to the unplug phase. Pressing 1, it is asking for entering your pin. Now what happens, you forget your pin, so you're entering it wrong. It is displaying wrong password, and again it is giving you 2 chances to enter your password. We can extend it further for 4 to 5 chances. Now the door is blocked and you have to call master person to open the door. Now the authorized person only knows how to go to the master code phase, because the user don't know what to do next. Now there is a specific way. If you press 4, then only it will give access to enter the master number. Now enter the master number which is given by you, the company people. Then after that, the mobile number is displayed of the user. Now the authorized person do what? It will call on this number and make sure that the battery belongs to the same user. Now this way we are providing high security to our users. Our project has many advantages like user convenience and safety measures. User convenience is provided by it is very easy and cheap to use, and it does not use multiple cables for different mobile sets. It uses a universal charger which sets for all kinds of batteries, and safety measures is provided by our door locking mechanism and our master phase. And at last, I would like to thank you, Texas Instruments, for giving us such an opportunity.